Comes out of section 5.1, vertical asymptote. In our last example, we basically found that if you had a function, and as you approach some value from the left, if you got infinity, or if you approached it, from the right or the left, and you got infinity, so you'd have vertical asymptote. Same true if you approach the value from the right or the left, and you get negative infinity. What that means is that it also means that you have a vertical asymptote there. It just means that you're approaching it in a different way. So here, you're going to be approaching it either like this or like this, and over here, you'll be approaching the value of a like this or like this. So what we'll do for the most part is deal with rational functions that have a polynomial on the top and on the bottom. We look at the non-permissible values where the denominator is 0, and find the limits from the left and from the right. So let's do an example of that, because it's always easier to do really. So we're asked to find the vertical asymptotes for this function, y equals x over x squared minus 2x minus 15, and sketch the graph near the asymptote or asymptotes. The first part of this, again, is not really anything to do with calculus. It's a factoring question to say, okay, can you figure out what the zeros are of this thing? And then you say, okay, well, if I had x equals negative 3 or x equals 5, I potentially have asymptotes there. At the very least, I know that my graph is undefined there. So those are non-permissible values. I don't necessarily know for sure that they're vertical or horizontal asymptotes. So what I do is I say, well, what's the limit as x approaches negative 3 from the left of this function of x plus 3 times x minus 5 under x. So what's that going to look like? Well, I'll have a negative number on top, because negative 3.0001 is a negative number on top. On the bottom, I'll have a tiny, tiny, tiny negative number times another negative number. Now, that's not real technical terms there, but if you have a negative divided by a negative times a tiny negative, first of all, you will end up with a negative answer, and because this tiny negative number is in the denominator, you end up heading towards negative infinity. So what does that mean? It means that as I draw this graph at negative 3 from the left, my graph is doing this. Now, I don't know anything else about that without doing more work, but at least I know that much. Now, if I do the same thing, the limit as x approaches negative 3 from the right, so a number like 2.99999, negative 2.9999, that is, I'm going to have a negative number on top again, but on the bottom here, this becomes a tiny positive number times a negative number. So in this case, your negatives cancel out and you head towards positive infinity. So as I approach from the right, on this side of the asymptote, I've got that. So that's what I mean by sketch the graph near its asymptote. So if you do the same thing as x approaches 5 from the left, you're going to have a positive number over a positive number times a tiny negative number, because if you approach from the left, you got 4.99999 minus 5, tiny negative number, and so you again approach negative infinity. So if I go 1, 2, 3, 4, 5 over here, it turns out I do have vertical asymptote, and I'm approaching negative infinity on that side of it. The final piece of this puzzle, as x approaches 5 from the right, this function is going to give